Yeah, let's get radical and simplify some radical expressions. Simplifying radical expressions. If that sounds familiar to you, chances are you've seen it in Algebra 1 and or Algebra 2. After we do an example or two, you might say, hey, I remember that. Maybe you don't really remember it. Maybe you've never seen it. That's okay. That's the point of this video. It's to refresh if you have seen it, and it's to teach how to do this if you haven't seen it, because we're going to need to know how to do this for some future topics that we're going to be doing when we come back from fall break. Oh, fall break. It can't come soon enough, can it? We all need a break. We all deserve a break. What I need you to do is to, before we go any further, I've listed 12 perfect squares. I need you to write those down. Please pause the video right now and write those down. Now, I want to say something about this list of perfect squares. The first is you do not have to memorize it. You can always reproduce the list of these perfect squares on demand, and here's how you go about doing it. If you wanted to reproduce this list, because memorization is good for some things, but memorization usually isn't good for math. There's a process that you can use. How did we get 1? Well, we got 1 because 1 times 1 is 1. How do we get 4? 2 times 2. How do we get 9? 3 times 3. You can always reproduce this list. You need not memorize it. Before we go any further, I have one more note to say about these perfect squares. Notice the word sum. I have only listed the first 12 perfect squares, but there are many, 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 many more. Infinite perfect squares. There's no way to list them. Hopefully, these 12 we have in a list will be enough, and we don't need to worry about going beyond 144. But if we do, you know, it's no big shake. It's going to be a rare occurrence that it happens, but I just want to point out it's not like these are the only 12 perfect squares. There are other perfect squares beyond 144. With that said, let's keep rolling. So this is going to be our basic setup. You're going to be given some, in most cases, a non-perfect square number. Non-perfect square number. Now, what do I mean by that? Non-perfect square. Non-perfect square is a number that's not a perfect square. A number like 18 is a good example. 18 is not a perfect square. A number like 38 would be another example of a number that's non-perfect square. The reason why those numbers are non-perfect squares is because there is no whole number that you can multiply by itself to give you, for instance, 18. I mean, think about it. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. You've already passed 18. We have to find a way to still be able to deal with these kinds of numbers, and here's what we're going to do to deal with them. What we're going to do is we're going to break number up. We're going to smash it to, well, I guess not to bits, but we're going to smash it into 2 pieces. The first box is going to be for our largest perfect square factor. Wow, that's a mouthful. Largest perfect square factor. The second box is going to be for the factor that remains. Or I'll just say remaining factor. All right then. Right now, this is probably clear as mud. You're looking at this and saying, I have no idea what he's talking about. I'm so lost. Don't worry. It's going to be okay. I promise. We're going to do an example together, and when you see it, you're going to be like, oh, is that all? That's all it is? Why didn't you just say that, Mr. Miller? Let's get right into it. Let's take a look at our first example. Make sure I still have the pen going here. All right, so we need to simplify the square root of 18. 18 clearly is not a perfect square. When we look at our list, 16, and then we go to 25. Hey, 18 somewhere in between there. It's not a perfect square. So what we do is we look at our list of perfect squares, and we try to find the biggest perfect square on this list that divides evenly into 18. So, of course, 1 is always going to work, and so I don't recommend starting there because 1 is always going to work. How about 4? 4 doesn't go into 18. How about 9? Oh, there it is. 9 is the number that we need. Now, before we go any further, is 9 the biggest perfect square, though, that divides into 18? Well, let's check. 16 into 18. No, I don't think so. That's not going to work. And 25 is way too big. No way it's going to divide into 18. So it's 9. I ask myself, well, what do I need to multiply by 9 by to take me back to the 18 I started with? What times 9 is 18? Dose, right? 2. But we can simplify this even further. What we have there is all well and good, but we can simplify this further. What is the square root of 9? 3. It's 3. Drop down our box 2. Now, think about this for a minute. What happened to my square root? I went from square root of 9 to 3. Where'd the square root go? The square root processed that 9 and produced 3. The square root has been used. It is gone. It is nowhere to be found. You use it. Square root of 9 is a regular 3. That's it. That's the answer. Now, maybe 18 was kind of an easy-ish example, but I want to show you something. If you're having a hard time trying to find the biggest perfect square from the list that we have here, on the side you can fall back on this. These, I guess factor tables or t-tables. They were called t-tables when I was in elementary school. I don't know if they're still called that now. But let's just think of all the ways to multiply to get 18. 1 and 18, 2 and 9, 3 and 6. 7, 8, 9. We already have 9, so we're good. We've got all the possible factors. And we look at our 6 numbers in our t-table. What's the biggest perfect square in our list over here that matches a number in our table? The biggest perfect square is 9. Okay, and then that would take you over to here. You would drop 9 in, square root of 2, 9 through, boom, got your answer. All right, now, let's do another example together. Square root of 24. What's the biggest perfect square that goes into 24? What are you thinking? 9? Did you really just say 9? What is it? It's 4, right? It's 4. So we're going to break up 24 as 4 and what else? What times 4 gets me back? 4. 6. Beautiful. What's the square root of 4 now? Square root of 4 is 2. Drop down square root of 6, and boom, we have got our answer. All right, now, next 2 examples are for you. I'm going to show you the example. I want you to pause the video. I want you to work it out, and I want you to hit play and check this out. Matches mine. All right, check it out. I got 4 square root of 10. Here's what I did. I said, okay, what's the biggest perfect square that goes into 160? I got 16. On the side over here, I also demonstrated, if you needed to, how to do the t-table or the factor table. Once you have the factor table completed, if you do need to do this, you then try to find the biggest perfect square in your table that's also in our perfect square list. And that was 16. Get rid of 16 is 4. Bring down the 4. Get rid of the square root. Drop down square root of 10. Boom, you've got the answer. And I had to entertain myself a little bit. So I kind of I'm getting a little slap happy now. Sorry about that. Last example, same thing. Pause the video, work it out, then check your answer. Here we go. All right, so check it out. I got 4 square root of 2. The biggest perfect square that went into 32 was 16. 16 times my 2 is going to take me back to 32. Square root of 16 is 4. Drop down square root of 2. Got your answer. Now, if you didn't see 16 right away, you can always fall back on doing these factor tables or t-tables. The biggest perfect square is 16. I didn't take the scenic route this time. I just went straight there, drop in my 16. Square root of 16 is 4. Drop down square root of 2. You've got your answer. Last comment. These t-tables that I did on the last example and this one are not mandatory. You don't have to do them unless you need to do them to find the perfect square that makes that magic happen. All right. That concludes the video. Thank you so much for watching and your participation. What I will need for you to do now are these things. Please do bring up your Chromebook with A28 open for the password. Also bring up your notebook so I can the notes that you took on this hopefully somewhat entertaining video, and check your notes from previous days when we took notes. In other words, I need to grade your notebook. Long story short, I need to grade your notebook. After I check over your notebook, I will then type in the password to A28. You'll work on A28, and after that, you can enjoy the rest of the time that remains. You may listen to music as you're working on A28 also. With that said, adios.